All right, let's talk about experimental design, even though that's not what this says. It's experimental design, though. You're supposed to watch a video, so hopefully you've clicked that link on the PowerPoint and you watch it. Okay, hopefully by now you've paused this video and went and watched it, but basically they were giving water to people. Like they said, hey, come hit the carnival hammer game thing and see how high you get. And then they gave them this supposed energy drink that was supposed to really hype them up, and it was just water and everyone did better. So that's the placebo effect that they're trying to show. They didn't really do a good job of it because it was for a TV show, right? For this TV show, they're hyping people up. They're trying to really convince them that this is working. But that's not what the placebo effect is. It's not a bunch of external factors making you think that it's actually working. It's just supposed to be the act of taking it convinced you that it was working, not also this lady hyping you up after that. So they didn't do a great job of that, but it's because it was for a TV show. They needed things to work. Now that said, similar to video, say I want to use a beverage to test the effect that caffeine can have on heart rate. So my initial plan is to measure their pulse, give them some caffeine, we'll do it by Coca-Cola, wait for a specified time, measure final pulse rate, and then compare the final and the initial. What might be some issues that arise from this plan? I don't know what I'm waiting for. There's no one in front of me. Like, I'm looking out a window, so it's funny that I waited for that. Anyway, some issues that could arise is maybe it's just sugar. That's not how you spell sugar. Right? Maybe the sugar is what's raising these people's heart rate. It doesn't necessarily have to be the caffeine. So that's one thing that could go wrong. Another thing, I haven't really said what they're doing there. Like, what if they're going on a walk in between? That could raise your heart rate. Maybe not a lot, but it could. Right? So in fact, I think we're kind of answering both of these questions in one go, right? What other variables might come into play? The sugar in the Coke could do it. What they do in between could do it. People not knowing how to measure pulse effectively. Not understanding how to measure pulse. Right, there's lots of different things that could come in here. So these are all things that are going to increase our variability. Maybe they'll even make us a little biased in our results. But those are things that we have to account for. When people are designing experiments, they have to be very, very thorough. And there are actually some principles of experimental design, and we're going to get there now. The number one principle is comparison. You should have at least two groups, one of them being a control. Maybe you don't use a control group. Like, if we used a control group, maybe caffeine-free Coca-Cola would do it, right? That way it's like everything is exactly the same, except this one doesn't have caffeine. That'd be a great way to have an experiment. Put it in a little paper cup so they don't know which one they're getting. That'd be great. But I need a control group to compare because I need to know, okay, well, is it just that they did this thing that changed it? How do I know what would have happened if they didn't do that thing? You also need random assignment, which we talked about in the last video. We have to have random assignment because otherwise there might be a reason someone's picked the group that they're in. Eliminate is the wrong word. Reduce is always the word. Can't ever eliminate it. We can just reduce it as much as possible. So let's get rid of eliminate. Control variables. Now, this is not control group. It's the verb control. You need to control your variables. Making sure that all other variables are held constant. So with us, it'd be making sure people stay seated in between. That way they're not doing something that affects their heart rate. Maybe even keep their eyes closed for the entire experiment, something like that. We need to make sure that nothing else could be affecting their pulse, right? So it's not control variables, it's control the variables, like a verb. Last thing is replication. Now, this replication is not really the sciencey version of replication that you're used to, where it's like, okay, now go run the experiment again and go run the experiment again. in statistics, when we say replication, we mean your experiment shouldn't just be done on this one person. Your experiment should be done on several people, like 100 people should be in this experiment. And that's the replication we have. You need lots of experimental units. The reason that we do that is because people are different, right? People vary. So looking at 100 people rather than looking at 10 people shows us some variability that we weren't able to control for. And so then we can really, really see, okay, it was the treatment itself that did it. All right, the first type of design that we're going to do, and we're only going to do one in this video, we'll do another one in another video, but is completely randomized design. It's a design in which every experimental unit is assigned to a treatment group randomly. You just look at everyone and you do a random assignment. Each experimental unit has an equal chance to be assigned to any treatment. You don't have to have equal-sized groups, but it's nice, right? It's not necessary, but it is useful if you can make that happen. A drug company wants to design a completely randomized design to test a new fever medication, a 325 milligram drug, against a placebo group. Describe a completely randomized design using the 1,200 subjects they have. So first of all, I'm going to split this because we're going to end up doing two things as a result of this. We're going to start with the 1,200 subjects. And then we're going to do random assignment to them. Group 1, we'll say gets the drug. And group 2 gets the placebo. Should also say how many people are in each group, so 600 subjects. And then afterwards we compare, I guess, fever reduction. So that's the outline for the experiment. That's what we want to do. Now, this random assignment that's over here, I need to explain how to do that. So to do the random assignment, I like using a random number generator. I hate using a random number table unless I have to. So we're going to label all the subjects. One through 1,200. Randomly generate (600) unique, right? That's our ignore repeats thing. These are group 1. Remaining subjects are group 2. You have to be that thorough. You have to explain every little thing. An idiot should be able to do it afterwards. All right. Blinding, I briefly mentioned this, I just didn't really say. But blinding is when the experimental unit does not know to which treatment they belong, right? So I explained that with the Coke versus the caffeine-free Coke and put it in a paper cup. They can't tell the difference. They should taste pretty much the same, right? That's what I want when I do my blinding. I don't want the experimental unit or the subject to know what group they're in. This is mostly with humans, but it could be with other things as well, but nothing comes to mind. It's primarily a human thing, that placebo effect, because, I don't know, if you give a cat a medicine, a cat doesn't know the medicine is supposed to help them, right? But a person takes medicine, they expect a change, they expect a result, and so their brain can trick them. So we want to make sure that they don't know whether they have the real drug or the placebo, or in our Coca-Cola case, the real Coca-Cola or the caffeine-free Coca-Cola. We don't want them to know that because the act of knowing can trick their mind into thinking something. Say you're a researcher with a new medicine to try. The company that makes the medicine is sponsoring your research. Why is that bad? The company probably wants the research to say the thing is working, right? The company wants the medicine to be functional and working because they're trying to sell it. That can come with some ethical dilemmas, right? So something that can help us get away from that is double blinding. So in blinding, the subject doesn't know what group they're in. But in double blinding, neither does the researcher. There's some neutral third party that does the assignment, and the researcher asking the questions to the subject doesn't know what they're getting. That's useful because now the researcher doesn't see someone that got the drug and be like, well, they should be experiencing this. And maybe they hear what the person's saying a little bit differently than what they actually might have been because the researcher had expectations. So the human mind is unfortunately tricky. So you have to trick it back so that way you can make sure everything's above board. Okay, bye.